In those first tens of minutes, it is extremely difficult to manage and deploy units to effectively tackle that extraordinary event. Drone use basically means instant deployment, and instant detection during the rapid spread of toxic substances is priceless, as speed is of the essence in such circumstances. The goal of the Fire Sensors project is the development of a drone-mountable system to provide an incident commander with real-time information about an environment almost inaccessible to humans. Be it a forest fire or a chemical plant gas leak, a drone could distribute sensors autonomously. These would then send information on air composition, temperature, and anything else. It is possible to measure not only temperature and humidity, for example, but also dangerous and explosive gases, and even radioactivity can be measured. We have built the system to be as versatile as possible. We have a brewery in our town that uses ammonia for cooling, a highly toxic substance. We are able to measure temperatures, impact distances, and so on. The resulting application would create a dispersion map, which would also be available online for the integrated rescue system, password protected, of course. Any incident commander, even a policeman with a mobile phone, would be able to see if an ammonia cloud was approaching, or whether units should be dispatched to that location. If I am able to deploy a sensor that can transfer relevant data, I am also able to deploy such units effectively and deploy them wherever they are needed first. In cases where these sensors are somewhere en route, they can already identify, for example, whether concentration is increasing in that direction and if care should be taken. The source of information is one of the most important links in the command chain, and if we can learn to work with it, then interventions will become significantly more effective and individual emergency services will be further protected. What we can see here on the table is actually the fifth version of our sensor design. The bumper has undergone the greatest changes throughout development, as it was necessary to determine material, thickness, deformation, how to shape it, and so on. The tail section houses all of the sensors, and the interior of the body is rubberized, and in this airtight container, all of the electronics are sealed against its surroundings. Some of the more aggressive gases, such as chlorine, can cause severe corrosion and can significantly reduce the lifetime of the electronics. This is how the finished product looks, and this is ready to deploy. The bomb bay actually holds the sensors one after another in 3 rows, and when one is needed, only the first sensor is exposed. The sensor flips vertically and is deployed. The system consists of a basic control unit, which is the central brain, and the power supply. There is also a measurement unit, mathematical processing, assessment, and once the system is in place, it activates, begins measuring, and sends you data. Further development will definitely involve miniaturization. This is still in the prototype stage, so there are a lot of extra electronics. We need to trim this down, maybe even reduce the size of the sensors, which would reduce the overall design and enable us to release more of these units. Not just 9, but maybe 18. The actual impact of this sensor system used to cause real deformation. The electronics suffered quite a lot. That's why we use a laboratory with computer tomography, which helps us see inside the sensors and inside the electronics where we can search for defects. We have also done mechanical tests, especially with the bumper. If you can imagine that it falls like this from 15 or 20 meters onto hard ground, the mechanics of that bumper are exposed to very, very high G-forces. In order for us to see whether the system can survive, even in harsh outdoor conditions, we have tested it in so-called climatic chambers. With this kind of testing, we can simulate the device being in an outdoor environment, for example, for several months up to several years. This system contains an ammonia sensor that we manufactured. The calibration was also carried out in our laboratories. We are able to expose these sensor elements to specific defined conditions that simulate real-life conditions in which firefighters intervene. And if the ammonia sensors detect predetermined concentrations, we can trust that it is giving us a correct and relevant reading. Of course, we are currently dealing with legislation. Legislation is in its infancy because the technology is moving faster than the lawmakers, but that is normal, as something must settle in the field of technology first. But we do not want to completely give it the green light yet, in the sense that it would be free to carry anything and deploy it anywhere. This presents a very high security risk. But if we are able to use it effectively to guard health, to save lives, to protect property, it makes sense. And that, I think, is essential.
Myslím, že zcela zásadní.